Today I'm going to explain to you how to use PlotToSat for generating time series of satellite data from multiple plot locations. PlotToSat takes as input a CSV file containing the plot information. The user can use Sentinel-1, Sentinel-2 or both datasets. They may choose to apply some mask for data cleaning. The time series are exported into separate CSV files to their Google Drive. Once they download this file, they can merge them using a provided script. PlotToSat is an open source software that is available on GitHub. And here is the user guide. To run it, I use Visual Studio. You can use Jupyter Notebooks, and you need to download Python and to have a Google Earth Engine account. If you don't have a Google Earth Engine account, there is a video link below where it explains you how to create one. There are some dependencies that you need to install. If you go to the installation part of the user guide, you can copy and paste it. It will install whatever packages you need. PlotToSat is implemented object-oriented, which means you have different modules. Each module is associated with a test, where you can go and have a look into it and understand how you can use these modules independently. The PlotToSat class is the one that links all the modules together and helps you produce the time series. There are two test cases associated with it. The first one includes the essential commands that you need to run the software. So you need to define a study area. You need to give some information about the field data, which is the location of the CSV file, the coordinate system. PlotToSat assumes that the plots are circular, so that's why you need to give the radius. The radius is consistent between the CSV file. And then you need to define the name of the columns that contains the coordinates. This is an important parameter because PlotToSat exports this file. It copies and pastes the plot information, and it adds an extra column with identifiers. These identifiers are used later when you use the merging script to merge the multiple files that are exported on your Google Drive. If you're running PlotToSat multiple times, you need to give different names to make sure you don't override it. You define the year of interest. PlotToSat only works with 1 year each time, but you can run it multiple times to get many years. And then you create an instance of the PlotToSat class. So once you define an instance of PlotToSat, you can add Sentinel-1 or Sentinel-2 collection or both. Each one of them takes as input as a parameter. Regarding Sentinel-1, you can say true if you want to keep only the non-shaded areas. And this is useful for maintenance areas. Here is an example. So you can see that these are the non-shaded areas and this is the shaded areas. And this is what you get. Regarding the Sentinel-2 data, you say how much cloud percentage you want to remove. So if an image contains more clouds than the threshold given, this image will not be included in the calculations. But also cloud masking is applied, so you don't need to worry particularly about it. You also need to say the start name of the CSV files that will be exported. And define the name of the folder that will be stored on your Google Drive. To run this, we need to choose that we're using Python. So now it's running. I need to authorize to give access to the code to use Google Earth Engine. Do not press this button because PlotToSat does not only read data, but it also writes data on your Google Drive. So you say generate token. You choose the account that you want to use. If you don't have an account, please use the tutorial below to create one. And then you need to select both here. And continue. You need to take this token, copy and paste it here. And now you have successfully authenticated Google Earth Engine. Here it gives you some useful information. It tells you which collections has been added. And this is an important one because it tells you which bands are found. If this is empty, it's probably because there are no plots within the study area that you've given to the software. You can track the process using this tab here. So if I refresh, you can see there are already 4 tabs here. In this case, it exports 400 plots in each file, a different file for Sentinel-1, a different file for Sentinel-2. It gives you the mean and the standard deviation for each one of them. Once the files are exported, you need to find them on your Google Drive. It's worth noting that sometimes it creates 2 folders with the same name and it shares the exportation. This means you need to download both folders and merge them. And this happens because Google Earth Engine is a parallel computing engine. If it happens to write the data simultaneously, it will create 2 folders. I can download this folder here. Before I go to the merge script, I will explain what's the difference in test case 2. Test case 2 gives a different way of defining a study area. In this case, I choose a country instead of a polygon. I give a different name for the plots with identifiers to be exported. And I also defined the optional masks of my interest. So there is a tag for each mask, and there are different properties that you can read about them in the user guide that you can add. It's usually just a buffer. The only difference is that for as masks, they also have a start and end day, and only the year is taken into account. You can also change the sampling. The previous test case was using 400 plots for each file it was exporting, while here I'm reducing it to 300. Google Earth Engine has a limitation of how many batch scripts you can use, so the bigger number you use, the better it is. But if you use too big, you will start bumping into errors. So there are 2 associated errors that you can tackle. One, you can increase the recursion limit, but be careful because the default one is 1000. If you increase it too much, it's likely that your PC will crash because it will not have so much memory to handle this recursion depth that you're defining. And the other thing is increasing this number, but it's worth testing with a smaller size to see which one is the most appropriate size. I did use 1000s before, but I think it also depends on how dense the plots are. If your plots are spread into many tiles and they're far away from each other, you may need a smaller number because it means it needs to process more data simultaneously, and that increases the depth of processing on the Google Earth Engine. There is another thing here. Very rarely, when you go to your task here, instead of having like a nice blue color, you have a red color, which means that this process failed. So you can use this command to process only the Google Earth Engine request that had failed. So when those processes are finished, the data are stored on the Google Drive. We can download the folder. So once we download the folder, we need to extract it before we use it. So here's our folder. And here's the merge lib that explains you how to merge this file. Here is the directory of the folder that we downloaded for Google Earth Engine and Extractor. And here is the directory of the plot data with the identifiers that we defined here. And then we create an instance of the merged library. We give an input the folder with the multiple plots. We give as input the identifiers and call the merge. And if we run this, it tells us that there are 2 files of each one, and then tells us where the results are saved. Here. So if I open the mains, so I've got all the information that they were stored into my plot data. Now these are my own identifiers. And then I have the SAR data, and then the spectral data, the Sentinel-2 data. There is a prefix in front of every band name, and this indicates the corresponding month. For example, 0 is January, and 11 is December. So it's important to remember that counting starts from 0. So I hope you found this tutorial useful, and please do not hesitate to get in contact if you have any questions.